All right, moving on, we're going to look at the last couple of questions in the task that I want us to look at, which re-emphasizes kind of the idea of D, and when we look at a parabola and we're solving using the quadratic function, what does it mean? So the very first question we're going to look at today, question number 3, they give us f of x equals x squared minus 6x plus 4. It says, so let's think about another function. It says graph the function by putting the equation into vertex form. All right, so over here I'm going to take the equation and I'm going to put it into vertex form. So x squared minus 6x plus 4. How do I put something into vertex form? Well, it's complete the square. Divide a, move c. In this case, a is 1. So x squared minus 6x plus something, and then 4 minus something. Well, you should remember now, by the time we get to this step, you take half of 6 and square it. So half of 6 is 3. 3 squared is equal to 9. 9 is what goes in the blank to make this a perfect square. So I can rewrite it as a product of squares. And then if I'm adding 9, I look at the a value. 9 times 1 is 9. I'm really adding 9, so I subtract 9. And then the next step here is my function in vertex form. X minus 3. Remember, I got to take half of that middle term. That's what my factor becomes. So 3, and then 4 minus 9 is minus 5. So here's my equation in vertex form. So that's what I'm gonna go ahead and do. I'm gonna put over here y is equal to x minus 3 squared minus 5, and then I'm going to be able to graph that because that's what it's telling me to do. Well, when I graph it, I want to find my vertex, identify the vertex. Well, remember, h and k tell me the vertex, so here's h, here's k, but you have to remember that little tiny thing you got to remember here, it's positive 3, not negative 3, minus 5. So there's my vertex. Then it's asking me what is my x-intercept? Well, my axis of symmetry. My axis of symmetry is x equals 3 because the x value of the vertex and the axis of symmetry are the same, so x equals 3. It wants to know what the x-intercepts are. Well, I don't know that unless I put it in a different form or unless I factor it. Wait a second, we can figure that out. First of all, don't get too far ahead of yourselves. Go back and find out where the vertex is. 1, 2, 3. 1, 2, 3, 4, 5. There's my vertex. Now, because I don't have x-intercepts, I'm not going to go through the process of finding out where that axis of symmetry is, which I already know what it is because I know where the vertex is. So this is the middle of my parabola. That doesn't answer the question where my x-intercepts are. And if you notice, I have this little squiggly line in front of it. That means approximate x-intercepts. I'm going to start with the vertex and I'm going to graph according to a pattern. My a value is 1. So since my a value is 1, I can move right 1, up 1. Right 2, remember that pattern of 1, 4, 9. Okay, my inputs are 1, 2, and 3. My outputs would be 1, 4, and 9. So 2, 1, 2, 3, 4. Almost at my x-axis. Over 3 and up 9. Well, there's 4, 5, 6, 7, 8, 9. And I just mirror that on the other side. Left 1 up 1, left 2 up 4, left 3 up 9, which if you look at your original equation, it says my y-intercept is positive 4, which that is 0 and positive 4. And I can go ahead and graph my parabola. Now pause if you need to and do that. Okay, now, it's asking, what are the x-intercepts? Well, my x-intercepts are right here and right here. And if you notice, they are in between whole numbers. That's exactly where they should be. They should be in between. So I'm going to estimate what those x-intercepts are. Me over here, I'm just going to estimate that it's 0.7 and 0. Because it's not quite to 1. And then if my axis of symmetry is 3, 4, 5, 5.2, 5.2, and 0. Again, that's just an estimate. I'm just estimating. Now, part E says estimate D. Remember from yesterday, D is this value right here. Here is D. All right? So what is the value of D? Sorry, I got to get me a different marker there. What is D? Well, from the axis of symmetry, count 1, 2, and some change. I'm going to say D is approximately plus 2.3 units. Would you agree it's the same the other way? Maybe you say 2.1 or 2.2. Somewhere around in there is my D value. What's that important of? Well, if I use this, if I simplify this using the quadratic formula, I can kind of sort of make some idea of what's going to happen here, because my axis of symmetry is 3, so I have this formula that I'm going to simplify, and when I get to a certain point, it's going to be x, it's equals 3 plus or minus my value of D, which is 2.2, 2.1, 2.3, somewhere around in there. That's what it's going to end up being. We'll get to that later, though. Okay? You'll see that when we actually simplify something using the quadratic formula. What is f of x at the x-intercepts? The f of x, the value, whatever output value I have at the x-intercepts, is always equal to 0. So f of x at the x-intercepts, it's always 0. Remember, whatever this point is right here, whatever its value, okay, it's going to be a decimal. Let's call it 0.78, or excuse me, 0.78, not 7.8. 0.78, and that's an estimate. Its output value is 0. All right, so if I had a table of values, if my output is 0, my input is approximately 7.78, somewhere around there, 0.8, whatever. Okay, what is the exact value of D? Well, how do I know what the exact value of D is? It's saying use vertex form and solve. All right, so we're going to use vertex form. Y equals, here's another problem solving thing today. Y equals x minus 3 squared minus 5. How am I going to use this and solve for D? Well, remember, at my x-intercepts, my output value is 0. So I'm going to take this y and I'm going to replace that y. Well, let me just do this. I'm going to replace that y with the value of 0, because I know it's 0 at the x-intercepts. Now I only have a problem with one unknown, and I can go ahead and solve. How do I solve? I solve by getting rid of 5, so I add 5 to both sides. So I'm going to do one step at a time. Is equal to x minus 3 squared. Now, I need to get rid of the exponent. It's the only thing I can do. How do I get rid of exponents? I take the square root. So I'm just going to put some justifications over here. Over here I added 5. Here I'm going to take the square root. So I'm going to take the square root of both sides. And watch, you'll see what happens. X minus 3 is equivalent to the square root of 5. And then the last thing I'm going to do is add 3. So I'm going to add 3 to both sides. And when I do, I can't combine 3 and 5, because 5 is a radical. So x is equivalent to, I'm just going to move x to the other side, 3 plus or minus the square root of 5. This 3 represents my axis of symmetry. So there's my 3. My plus or minus 5 is my D value. So what is plus or minus 5? Well, the square root of 5 is just a little bit more than 2, because the square root of 4 is 2. So the square root of 5 is actually equal to 2.1. So D is plus or minus 2.1. That's what D is. Remember, we estimated it at 2.3 or 2.1 or 2.2, somewhere around in there. The exact value of it is 2.1. We found that by solving for x, and we used vertex form. So now it wants us to find the x-intercepts using a calculator. Okay, so if we use a calculator, we have 3 plus 2.1, and we have 3 minus 2.1. What are those exact values? Those exact values are going to end up being 5.2 and 0.8. Those are my exact values. That's how I was able to find those. So basically what it's saying is when your x-intercepts cross in between when they're decimals, it's actually easier to find your x-intercepts using the quadratic formula. We'll find that out. Okay. So there's question 3, and then we're going to go on and do question 4. All right. So give me a second. Let me get rid of this stuff, and we'll come back and we'll do question number 4. And question number 4, we're going to do the same way. The process is still the same. The only thing that changes in number 4 is the fact that it has an a value greater than 2. So we get to review a little bit more about how to, we get to review a few more things. So 2x squared minus 8x plus 5. And I'm going to jam through this, and you need to pause. You can pause if you need to. Okay, the very first thing it wants me to do is graph, and it wants me to find a vertex and axis of symmetry. And it even tells me, use vertex form. Okay, so I'm gonna come over here and I'm gonna convert this to vertex form. Minus 8x plus 5. Hopefully you can see this a little bit better. I should have done this with red ink before. Divide A, move C. So divide A, x squared minus 4x plus something, 5 minus something. Now here's another revisitation of when A is greater than 1. I'm going to take half of that middle term, 4 divided by 2 squared, so 2 squared, which is 4. So 4 goes in the blank. How much am I really adding though? Remember, this A value tells me how many different like models I would have, okay, in my entire diagram. I have 2 models. So I really have 4 squares here and I have 4 squares here. So I have a total of 8. So it looks like I'm really adding 4, but I'm really adding 8. So 4 times 2 equals 8, so I have to subtract 8. And then the last step is vertex form. 2x plus or minus becomes minus. Go back to your original equation even. 2, remember this h value is what you took half of, squared. 5 minus 8 is negative 3. So here's my problem in vertex form. And I'm just going to rewrite that over here. So y equals 2x minus 2 squared minus 3. What is my vertex? Well, my vertex is positive 2. You got to remember that. It's the opposite. Positive 2 and negative 3. The axis of symmetry is x equals 2. So I come over here. X equals 2. Axis of symmetry, 2 and negative 3. There's my vertex. Now I can graph according to a pattern because it wants my x-intercepts. Well, you got to remember, the pattern now has changed. The pattern is usually 1, 4, and 9, but the pattern is dictated by the a value. Here the a value is 2, so it changes my outputs. So 2, 8, and 18. I'm probably only going to be able to graph these 2 points here. So I'm going to go over 1 and up 2, left 1 and up 2, that was right 1 and up 2, and then I'm going to go right 2 and up 8. So 1, 2, 3, 4, 5, 6, 7, 8, and then I mirror that on the other side, left 2 and up 8. My y-intercept in this case is 1, 2, 3, 4, 5, which if I go back to my original equation, the c value is 5, so I know that's correct. Now I can go ahead and draw my parabola, and if we notice again, my x-intercepts are going to be decimals. They're in between. So approximate them. Gee, this one looks exactly like the previous one did when I have 0.7 or 0.8. Let's just call it 0.8 and 0 because it's kind of close to 1. And this is 1, 2, 3 point something. Let's just call it 3.1 and 0. Again, all I'm doing right now is approximating. And then it wants me to estimate D. Well, what is D? D looks like it's about 1 point something. So I'm going to say 1.2, approximately 1.1, 1.2, somewhere around in there. Now, f of x at the x-intercepts. What is f of x at the x-intercepts? All it's asking there is, what is the output value for your input? Given an input, what is the output? The output is always 0. So always 0. What is the exact value of D? Well, how do I determine the exact value of D? I determine the exact value of D using vertex form. And G got left off. Part G got left off. So we're gonna use that. 2 times x minus 2 squared. So we're just gonna solve it. X minus 2 squared minus 3. I'm gonna plug 0 in because the output at my x-intercepts is 0. So I'm gonna use that to my advantage. 0 is equal to this, and I want to solve for x. So what do? Well, here's my justifications. I'm going to add 3. So plus 3 plus 3. So 3 is equal to 2 times x minus 2 squared. I got to get rid of the 2. So divide by 2. So I'm just going to show that. Divide by 2. Divide by 2. 3 halves. Yes, that's right. 3 halves. And that's going to be a fraction. That might be a little bit of an issue, but don't worry about it right now. 3 halves is equal to x minus 2 squared. I'm going to justify what I'm doing. Take the square root, because I got to get rid of the exponent. When I take the square root of both sides, I take the square root of the entire fraction. So I get the square root of 3 halves is equal to x minus 2. And then I'm going to add 2. When I add 2 to both sides, you'll see what happens. Plus 2, and I ran out of room over here, so I got to move this way. So here's my answer. My answer is 2 plus or minus the square root of 3 halves. Here's my answer right here. These are my x-intercepts. I move one positive, I move one negative. Well, 2 is my axis of symmetry. So 2 is my h value or my x value, whatever. The square root of 3 halves, that's my d value right there. That tells me where to go. So now we can actually find my x-intercept. So it's going to be 2 plus the square root of 3 halves, and it's going to be 2 minus the square root of 3 halves. Well, what's the square root of 3 halves? If you get a calculator out and you determine what the square root of 3 halves is, the square root of 3 divided by 2 is equivalent to 1.22, or it's approximately 1.22. So this is where you got to get the calculator out. 2 plus 1.22 and 2 minus 1.22. That's the way I figure out what these decimals are. Okay? So I'm going to have one x-intercept at 3.22 and 0. Okay? And then the other x-intercept is going to be 2 minus 1.22, which is 0.78 and 0. Now, what did we estimate them to be? We were kind of close when we estimated. 3.1, 3.22, off a little bit, 0.8, 0.78, off just a little bit. That's kind of a lot to chew, but the thing you got to understand and focus on is when we simplify using vertex form, we get to an answer like right here. Okay? You're going to get to answers like that when you use the quadratic formula, and they're very, very similar. All right? So we've got a few other things that we got to work on. Ask questions if you need to.